still a lot of confusion and misunderstanding around its implementation, such as its cost and time certification. How do you remember, again, ISO 9000? How many companies wanted to go for that until they realized the cost or the time or the commitment? I look back recently to, I'm not going to read this whole list to you because I think you can, but also I look back at Lean. I was in the manufacturing world when Lean came into play, when Six Sigma came into play. We merged the two, and I could go under for 5S, and you can just keep going through the whole system. And I think that is one of the biggest pieces. Adam brought up a point of our students learning about these different processes. It's good for them to know, because it's also good for them to know that even though they are going to be stewards or hope to be stewards of our habitat and our environment, sometimes a company has cost and time and personnel issues that they cannot do what most people would think is good for the bigger cause or for the the bigger picture. So again, we try and teach them that just because this doesn't happen does not mean it's a bad company to work for. Again, it's trying to teach them about sustainability, product development, the design and development of products that have a minimal impact in the environment. One of the things our students developed in the last couple of years are windmills that are now mounted on top of our one of our buildings on our campus that provide some energy and some learning processes for our students. So they've made them out of carbon fiber. The base is made out of filament wound bamboo. And so they're trying to use different projects and different processes to get to understanding about sustainability product development. And this requires a holistic procedure that now analyzes the total product development, which is what we call a life cycle analysis. Not to get too technical in this whole area, but one of the things we try and teach students when we are working with them is look at the end product. What is going to happen from the beginning to the end? That is really what this whole presentation is about, is asking them to understand about product take back. And that's the idea that a company that produces the product is responsible for its disposition at the end of its useful life cycle. That's probably one of the most discussed topics when we talk about this in our classroom and our students, and when they're out there trying to find different processes and projects and materials to use in their projects, in their second year projects. So they have quite a discussion about this. So again, we try and infuse design in first thoughts. It's initial decisions about product features, materials, related processes, the effect overall life cycle, and the product based on raw materials process used for individual components. Systematic design reviews can help evaluate some of those various design decisions and manufacturing and costs and useful service life of individual components. Why is it important? Again, we use, again, the pencil that I was sharing with you earlier. We use that to show them the different processes of what can happen when you have genes, or how some students, when we do talk about that, they'll say, well, I can either do that, or remember when there was people on the street, they remember this, that you could sell your Levi jeans that were 20 years old to somebody on the corner. I don't know if you had that. We have that a lot in Seattle. So let's say, why do we do this instead of just selling them? It's because you can do something else with them. You create a whole new project, a whole new product out of it. So when we're talking again to them about basic design, environmental considerations are very important. And we go through this process in the design phase, that we want them, as they select their product, to reduce the amount of raw materials, reduce the amount of components, reduce product energy requirements. These are challenges that we give them as they're trying to develop their second year project and choose the materials that they want to. By the way, when they do their presentations on their second year projects, and they do it to the advisory committee, and oftentimes they will do it at a dinner that we have for all advisory committee members for our institution, for all programs, they talk about why they picked the materials they picked. And on May 2nd, we have brought this down into the high schools. We call it the Manufacturing Education and Training Exchange. We have students that are around the area that are bringing in exhibits and projects that they've been working on, and while they tell us about their project, they also have to tell us the materials they selected and why they picked those materials. So we're infusing this back into the high schools, which has been very interesting, and they've really, it's been a challenge for them to identify and look up, it's hard enough for them to do their designs and whatnot, but also to look up information and properties about the different materials that they want to use. Some of the traditional considerations that we also use is, of course, market and end user demands, they're driven by design, product function, structural requirements, environmental durability requirements, aesthetics, what does it look like, individual component cost, production method, cycle time, and final product cost. So those are all traditional considerations, as you know, when you're doing material selection within manufacturing. But now we've added this component, which is the sustainability considerations when our students are selecting their materials. Useful life cycle, overall energy footprint, module design, design for reusability, design for disassembly. Once it's done, how are you going to disassemble it? Separation techniques, and ease of reuse and recycling. So in closing, I just wanted to share that my colleagues have done a great job about talking about our workforce connections, our partnerships, everything that we've talked about, the different programs, the different concepts, the processes. And our college is no different. We are looking at some of those very same issues and concerns and wanting to expand in those areas and focusing. But one of the things we, again, try and teach our students is material selection will always be a compromise of competing considerations. Therefore, it's important to remember a few key facts: that all materials are recyclable, however, some are more difficult than others. Reuse and recycling of raw materials minimizes energy, consumption, pollution, and human injury. Design for disassembly must be an integral part of design consideration. And material selection must include a complex set of considerations, and proper eco-labeling is helpful. Be honest, be truthful with when this piece is, again, we talk to our teachers, our students, and when they're presenting their pieces for the different advisory committees, they have to be able to answer some of these questions as well. And especially the last one is proper eco-labeling is helpful, is just making sure that they understand what they're really sharing. So there's a vast array of raw materials, and as you know, if you're familiar with material science, you know there's many more coming on. There's always what they call exotic materials, new materials, things like that to choose from, and the list just keeps on growing. So it's important to understand that material selection must, beyond functional consideration, be done to minimize the impact on the environment, and whenever possible, its restoration. So sustainability requires a proactive strategic construct, which is the loss of resources and habitat is relentless, but along with developed nations and as third world countries continue to develop, more stress will be placed on this planet. And that's the piece that we want our students to understand, of how important it is when you select that material to really understand what it's going to do, how it's going to react, how long will it take to biodegrade, that sort of thing. And get them to really understand that their decision early on in the design process is critical, not at the end, not when it's getting ready to be thrown out into the landfill, but early. And what we've seen is our students will start with a project, and as it evolves, we see it happening, the lights come on, and it's great to see them really concerned and really considerate of the environment and the impact that they will make with their project. So with that, I will close. And our website is up there, which is www.materialseducation.org, and we have quite a few modules on different types of materials, composites, you name it. You can go on and find different labs, modules, and information resources that you might be able to use in your programs. So thank you.